So for my project, for my lab here, I've done my getData.py function. Here, what I do is I create a final data frame that uses the dates as that just keeps all the dates that we're using for the range we're collecting. Then for all the symbols that we want to use, I go into the data folder and then get the path for and then find the CSV for that symbol. Then I read that CSV using the pandas read CSV, put that in a temporary data frame, then rename that data frame, rename the adjusted close column on that data frame to the name of the symbol, and then I merge that with the final data frame. And then once we've done that, and then I drop the any empty rows in that data frame. And then we loop that for every symbol that we want to test. So for example, here we're doing Google, Apple, Gold, Exxon, and SPY. And then we return the final data frame, which as you can see here, cuts out the week any non-trading days, such as for example, the 5th and the 6th of January, which is a weekend. And then for the assess portfolio, so first we do portfolio value, where we normalize the portfolio. So first I create a new data frame using the old prices data frame, and I also create a placeholder I. And then I loop through every symbol in the symbols that we're using. I create a series for that row of the normalized prices. Normalize that price using the first day, which is the 2nd of January, as the first is a holiday. New Year's Day is a trading holiday. So I use the price from the 2nd of January, and then I multiply that by the percent of the portfolio that's allocated to that specific stock ticker, and then I save that back into the normalized prices array, and then I increase that by 1 because allocs is a standard Python list instead of a data frame, so you can't use the symbol here. And then once we've gone through everything and normalized its prices and allocated it, we then sum up the allocations for each day, multiply that day's allocations by the starting value, and save that in a separate series called portfolio value. Rename that series to portfolio internally so that when we print it out, it's displayed properly, and then return it. For portfolio stats here, to calculate the cumulative return, we just take the portfolio value for the last trading day of the year minus the first trading day of the year, and then that whole thing divided by the first trading day of the year. For daily returns, we get so to calculate daily returns, we use the percentage change function from pandas on the portfolio value and then drop any empty values, and we do the same thing for the market. So the average daily returns is just the daily returns calculated here, the mean of that series. And for the standard deviation of the daily returns, we just take the standard deviation using the Panda standard deviation method. For the Sharpe ratio, we need to get the average daily returns minus the risk-free rate, and then divide that by the standard deviation of the daily returns. And we need to multiply this whole thing by the square root of the samples per year, which is the number of trading days. And then that gives us the value of the Sharpe ratio. And then to calculate the alpha and beta, we can use that by getting the linear regression of the market returns versus the portfolio's returns. So we use the linear regression function to get the slope, intercept, and other values that it returns as well, and then just store the values of slope and intercept as beta and alpha. I didn't do the optional stats, but because I didn't know how to calculate these, but we didn't have to; those were optional. For the assess portfolio, one last thing, we have to calculate the plot here. So I take the data frame of the combined stocks here, and then we get the dates that using the index of the series, and then we plot the dates against the portfolio and label that line as portfolio. Then plot the dates against the normalized prices of the market, which we're using SPY, and label that as SPY. And then we just use the title, label that are all provided in the args, create the legend, and then print out the plot. And then for the final assess portfolio function here, we use the start date and end date to create a date range. The prices, we use the get data function from the previous file here to get the data for the program. For SPY, to get the prices for SPY, we do the same thing but just with the SPY instead of using the whole array. To calculate the portfolio value, we just use the get portfolio value function from earlier. The end value is just the portfolio value at the end of the year, so the 31st. The rest of the stats were calculated using the get portfolio stats function from up here. And then we calculate the returns and market returns here again because we need to use the combined returns for the both the correlation function here as well as for the plotting. For the correlation function. And then for plotting, we have to normalize these functions again separately, which we can't copy the one from earlier because it's in a separate function, so we have to do this step again. And then we can plot the normalized data with creating a plot, and then also print all the data to the console, which we just print like this. We put a bunch of tabs here in order to make everything spaced the same way. So now if we run this function using the symbols Google, Apple, Gold, and Exxon, we can see that we get all of these values here in the terminal, which are the same as the given outputs in the program, and this plot here, which is the same as what was given in the program.